All right, here we go. Home stretch, everybody. Analysis variance, factorial ANOVA in R. One thing we haven't talked much about is getting means and standard deviations, so I want to drop that in here. The t-apply statistic is a useful one. What it does is it lets you break down variables in certain ways. So here I use t-apply to get the mean for testosterone, and I broke it down by, I used the command list to list two variables, region and condition. And it just gives me a little table here which has all of those means. You can do this with standard deviation, you can do this with variance, you can do this with a whole host of different statistics using the t-apply command to break down things. Another approach you could use, you can use the command with to tell R what data set you want to use, and then you can just do the t-apply command inside of that with the names of the variables without having to do the $ thing. Two different approaches give you the same thing. You can do that with a table command to figure out how many people you have as well. And just a few fun things with R. All right, for factorial ANOVA, factorial ANOVA in R and in other statistical packages can be a little challenging because the study of interactions is really something that is that's very prominent within psychology, but not in other fields. So when other fields use tools like ANOVA, they tend to use them in a way that that makes estimates in situations where we're assuming no interaction. We're really interested in the interaction, so I have to change a couple of the settings here. That's what this options command does, is it changes the default setting to something that's appropriate for the type of ANOVA that we want to use. I again use the LM command. I'm using the LM command here to run an analysis. I have region plus condition plus region colon condition is how I add in the interaction. And you can see I had comma the data file name there to indicate what the data is. And then the car package, I need a specific command called the ANOVA command that I'm going to run on this object, and I'm going to ask for what are called type 3 sums of squares. There's 4 different types of sums of squares. It's not really important what each of them does, but the important piece here is that it's type 3 that we want, but it's not type 3 that R has as a default. When we use type 3, we get all of those same values that we calculated. We see we get an F value and our probability values, just like we calculated by hand. And again, when I have the name of the package, colon, that's just telling R, get this specific command from this package. There's other ways to do this, but I've started using this approach exclusively because what it allows me to do is remember what different things came from what packages. For effect size, we use the LSR package, and within the LSR package, there's a command called eta squared, and we simply apply it to our the object that we built, the ANOVA 2F, and we want to, again, specify the types of sums of squares, and that's type 3. You'll see it gives us 2 values, eta squared and eta squared partial. It's partial eta squared that people generally present. What that eta squared statistic is it's the sums of square over the sums of square total. It doesn't do that partialing out piece. That would be more equivalent to what we did with the one-factor ANOVA, or would do with regression. Again, there's lots of arguments in the effect size literature, but people tend to use partial eta squared, so that's what I've focused on.